Hello everyone, this is Kalpana working as an assistant professor in SNS College of Technology at Artificial Intelligence and Data Science Department. Today we are going to discuss about circular queue. Let's begin the session. First, we'll see the purpose of the circular queue, why we need circular queue over our linear queue. We know the concept of linear queue, like it follows first in, first out principle, and when we are going to insert any new data element into a linear queue, we are going to insert at the rear end, and if we are going to delete any data item from the queue, we are going to delete from the front. Okay, that is the concept behind first in first out principle of the queue. Just imagine this is our linear queue. Now I'm going to delete number 25 and 30, 51, 60. Okay. Now at this situation, my rear is at last end. I reach the size of the queue. So at this position, can I able to insert any new item into this queue? No, it is not possible because according to linear queue, queue is full. It reaches the size. Rear reaches the size of the queue. So you cannot able to insert any new item into this queue. But just see, here I have deleted 4 elements. Now I got 4 empty holes in this array. But then I can't able to insert any new data element into this array. So this is actually a disadvantage of this linear queue, correct? So that we are moving to the concept called circular queue. We are going to use the space of the previously inserted elements. Let's see how we can do that. See the representation of the linear queue after deletion. So I have deleted 3 elements and my friend is here. Still then I cannot able to insert any new element into this queue. So this is the disadvantage of linear queue. Even though I have free empty spaces, I cannot able to insert anything into this queue. So to overcome this situation, what I can do is I can go with a concept called linear queue, circular queue instead of linear queue. So I am going to make my linear queue into circular with some modification, with some formula. Okay. Let's see what is that. So whenever I am going to insert any new element into the linear queue, what I will do, I am going to increment the rear pointer by 1. Rear equal to rear plus 1. That is the concept behind linear queue. But then to make this linear to circular queue, what I can do is, I am going to apply this formula. Okay, I am going to apply this calculation. Rear equal to rear plus 1 modulo size. I am going to introduce this modulo operator to make my normal queue, linear queue to circular queue. So let's see how we can do that. So this is my queue. So the size of the queue is like 0 to 7. So size of the queue is 8. Okay, I'm going to insert a new element into this queue. Let's consider this is my empty queue. Now I am going to insert number 50. Okay, element 50 into this queue. So initially we set front and rear pointer to -1 to represent the empty queue. Okay, -1. So here I'm going to insert new element. So whenever I'm going to insert new element, I need to focus on the rear pointer. At rear end only I'm going to insert. So here also I need to calculate the rear pointer, rear index value. Rear equal to rear plus 1 modulo size, okay. So rear value is what? -1. Right now it is my empty queue. So -1 plus 1 modulo size is 8. So 0 modulo 8 is what? It returns 0. So this is an modulo operator. So it returns 0 as such, because 0 is less than 8. So it returns 0. So my rear index value is 0. So I am going to insert 50 in 0th position. Okay. Till now we have discussed what is the disadvantage of linear queue and why we are going to circular queue. And in the next session we'll discuss how insertion and deletion is happening in circular queue. Thank you.